Live streaming is on.
Good morning, good afternoon, good evening. So it's again David broadcasting from the Senat Salle from the TU Delft. Actually, we didn't tell you, this is the room where all the PhD candidates defend their PhD, actually. We have today Francesc and Sergio, who will co-chair the sessions with us, with me and Mark. And Francesc and Sergio in some years will defend in this room their scientific findings as well. So don't put pressure. So for this day 3, we will speak about water and environmental health protection and see how microbial ecology can make a difference in this context. So we have seen on day 1 microorganisms and water resources. How can we manage microorganisms in different types of water systems? On the second day, we dig further into microbiomes, from the DNA to the RNA to the proteins to the metabolites, how we can look at the functionalities of these populations. And we went quite deep into these methods, notably, and their application in different types of scientific settings. And the question is always to see how can we translate that into practice, or how, from a practical point of view, we can also design some experiments and analytical plan to deliver the information that is needed for engineering concepts. And we have seen a nice session on theoretical ecology and engineering theory, where we described stochastic deterministic processes that can happen in water systems. Still the question, how can we include that into engineering aspects afterward? On this day 3, we'll see how we can gain the knowledge from day 1 and day 2, and to put that in the context of water, environmental, and health protection. There are 3 sessions. Again, first session on xenobiotics, xenogenetics. These are a bit barbarian terms, let's say, but it's to say all the chemicals and sets of genes that are released from our human activities and that propagate in the environment and can have problematic impact on environmental protection, on the environment, on health. We'll see how genes transfer in microbial communities and how antibiotic resistance emerge in wastewater treatment plant. Are wastewater treatment plant hotspots or not? And what about other types of water systems and the propagation of resistance? On session 8, we'll speak about water quality, health engineering, and education, and notably to see in the context of, for instance, in Ethiopia, in peri-urban areas, how can we use microbial ecology to address waterborne health issues. And in session 9, we'll speak about wastewater or water-based epidemiology and risk assessment. This is strongly linked to the COVID-19 situation, and we will have notably a keynote lecture from Colin Notown about the COVID poop-19 dashboard. So these are the sets of keynote presentation that we'll see today. So from Michael Gillings from Macquarie University in Australia, who will develop the rapid rise and dissemination of antibiotic resistance in the Anthropocene. We'll have some recreational part with the awards of the MIWI specialist group, an early career researcher award, and an Arden Lockett award, so it's more for more experienced researcher. We'll also deliver the poster awards that you have evaluated yesterday. In session 8, Adei Desta will give a keynote on agro-industrial effluents in peri-urban Ethiopia, about microbiology and the potential on public health impact. And Adei comes from Addis Ababa University in Ethiopia. And Colin Notown from the University of Merced will give a keynote on the COVID poops 19 and beyond, how the pandemic has changed the water sector. Before we start the sessions and the oral sessions, we will have the posters. And then before we go to the posters, let's try to bridge to Niti. Niti, are you here again?
Hello.
Good afternoon. How are you?
I'm good. Very good morning to all of you.
Thank you. And we'll do the same exercise as yesterday, and so with you, with Francesc and Sergio, to put down 3 main messages from what you gain from day 2. This is always an examination. So what are your message from the day 2 on microbiomes and functionalities and theoretical ecology, Niti?
Yeah, I think my major takeaway was the ever-going discussion we had yesterday in all sessions, I guess, about curation of metadata, checkpoints, the need for some extent of standardization, defining essential functions and markers. And I'd also like to highlight how we saw some awesome attempts in simplifying the complex results of microbial ecology through some amazing visualization tools in all the presentations that we saw yesterday. So that was really nice.
I'm typing down. Investigations. Yeah, great. Thank you, Niti. And Sergio, what are your messages from yesterday? Yeah, and therefore we do this take-home message in the morning to refresh on the main ideas. If somebody online wants to pop up and give a message, it's also possible. What did you learn from your talk? Maybe we start with the last one.
Sorry. Well, at the end, it's again what we were discussing yesterday is what she said, like that we need to standardize the methods that we use in the lab, also to make the metadata available. So comparison and maybe analysis by other can be done, not only focus on your.
Can you speak in the microphone?
Yep. Not only focus on your own data, let's say. So the availability of data.
Sorry. Problem with this keyboard. Should be made available. Yeah. So yeah, we have to translate this data into concepts, scientific concept, engineering concept. Need for translation into concepts. Related to that, when we discuss about the methods, how do you choose a method? There are so many methods in microbial ecology that we can use. And if we speak already with the omics, there are different scales of investigation. How should you use select your method? How do you make your choice?
Well, I think it will always depend on your research question that you should really plan in advance. Like, not only do like the method that you have available just because it's the one that is going to provide more data, but really think which one is going to be the most useful one, let's say.
Yeah. So if you want to get information out of a method, a measurement, you have to know why you want to do this measurement. And for that, you need to have a research question or an investigation question in practice that will help you to select the best method to answer this question as fast as possible and as accurate as possible and with the most confidence as possible. Yeah. Francesc, if you have also maybe 2 messages or 1 message.
A bit on the same line, we said there are many methods that allow us to study microbial communities, and somehow they generate more and more data per analysis every time. So one of the things we saw is that we can easily get, what we would say in Spanish, get drunk of data, so have way more data than we need. So there should be also a shift towards studies that take data from other investigations and see it from another perspective. No data waste.
Okay. And what about the theoretical ecology? What are the main messages about the second session of the day yesterday?
This was the difficult one, at least for me.
And why is it difficult? Maybe it's there that we have to put a message. Why do you think that it was a difficult session for you, potentially?
Maybe more conceptual and out of our view of microbial ecology, let's say.
Why it is the fundament of microbial ecology, or why maybe we don't say that the session was problematic. We said it was maybe difficult for non-experts to capture the main messages. And why is it so, do you think?
Well, I think the message was clear, mainly because the presenters made sure they conveyed it as easily as possible. I think the methods are still a bit difficult to catch for the, at least I would say for the average MIWI attendant, or I don't know if MIWI attendant is the word they want to say, but for the standard biological engineer, I would say. We saw the effect of deterministic and stochastic processes in the assembly of communities. And I think what I got from the talks of, especially from Ezequiel, that still the way to translate this into full-scale system is not clear, but is the way we should try to go. How this stochasticity affects full-scale microbial communities. And how, so one of the questions that was raised is how valid are our steady state experiments in the lab if the way the community is assembled is not always the same.
Yeah. Great. I will try to put methods here. Are there some comments online about this? Or is everybody agreeing with the messages that we set up here with Niti and Francesc and Sergio? So we have some time for discussion now. We still have 15 minutes, so maybe to switch on our brain, maybe one good way is to switch on our camera. We are not a lot in this early session. So if you switch on your camera, if you can do that, this would be great. And we can have now 10 minutes of 5-10 minutes of discussion. If you have other messages This is just a basis, so we are not judging the session, but we are giving some messages on here what the people thought about the different sessions of yesterday.
I'd like to say some. Hi guys, good afternoon from here. I just wanted to say that something that came up from yesterday in the session of theoretical ecology is that we do need to have conversations going between people working on full-scale systems and then people working in smaller scale systems like microcosm, mesocosm, or even modeling, right? And I posted a tweet where I show some figure from ecology where they discuss internal and external validity, right? And there is this tendency of people working on one side or the other side of the spectrum, right? Especially if one works in full-scale system, one can say with right that this is what represents the reality. But then at the same time, it's very hard to control a lot of different factors, right? So it's very hard to infer causality from that, which you can do from smaller scale systems, modeling or microcosm, mesocosm setups, right? But of course, there you lose external validity. So I think something that came up from yesterday is that none of the two approaches are absolute, right? So that we do need to have a conversation and it's cross-feeding from results on all sides of the spectrum, right? Modeling, smaller scale, and then full scale. So that's something I think came up from yesterday because the session had a good mix of approaches.
Yeah, the approach are very interesting. It's clear. It's, as I said yesterday, it's my fourth MIWI. I understand the theoretical ecology concept that are behind. I'm still wondering how we can integrate that maybe with other types of mathematical modeling methods that are used on the field, like these activated sludge models, for instance, where it's based on, because also the models in theoretical ecology are, some are based on Mumax, on KS, or affinity constant, on growth rate, on yields, etc. So we use the same parameters while they are used in different ways. And I think we need to, as for systems microbiology, we need to make the method explicit. It can be interesting to make the computational methods explicit in theoretical ecology so that the common MIWI delegate could implement that in a project. For instance, if Sergio and Frances could think, I would like to integrate that in my work, how can I do this? So probably we need also some small educational materials that we could also forward to based on the different sessions. It's not only about theoretical ecology, but can be on the methods for systems microbiology as well, multiomics, etc. Maybe from our specialist conferences, we could think that we could derive some small leaflet on 1-2 pages to describe a bit more in concrete terms what is the essence of these methods. I saw, for instance, for both on systems microbiology and theoretical ecology, we may think as well before we start a session like that we give a set of definitions maybe at the beginning so that everybody is at the same basic layer to be able to capture the talks afterward. So this can be also a way that we can better convey the messages and the findings and the methods to be implemented by others. This is a suggestion, but this can be quite interesting actually. And at IWA, there is also a specialist group for environmental engineering education, and with Nancy Love, we discuss to see how we could relaunch activities with this group. Should it be in a specialist group or should it be in a different way that, for instance, we could bridge to different conferences, and we try to generate some educational materials along with the keynote lectures and the oral presentation that we have. That can be very interesting because if you want to see the implementation of the nice methods that are developed, computational, bioinformatics, statistical methods, modeling methods, etc., or other analytical methods or experimental methods, we need to make clear how we can use them and implement them in our daily research. Because I'm sure that there are many people that are interested to do that. but sometimes they face a bit this inconfidence with the method, and we have to make the people confident to use them. Are there other add-ons online, on site? There's a microphone. Don't know, David? No, you will talk
Hi,
after.
good morning.
Yes.
So today I'm online, so I have to get used to
Hi,
on
Shaya.
the other side. Hi, good morning, everyone. Yeah, I would like to add something. You know, it's already been said that the usage of the data and the complexity of it is a challenge to tackle. But the nice thing about this conference is that I'm hearing it from different
Just a
perspectives.
question, can you speak in your microphone? It's a bit...
Yeah.
Yeah, it's better now.
Is it better now? Okay, thank you. Yeah, so what I sensed actually is that there is a lot of data, and we all realize from different perspectives that the complexity is a challenge to tackle. So I believe if we go with the hands-on deck purpose together with the researchers, the practitioners, and the people who are in between, the decision makers, for example, then we can bridge this together and in collaboration. That's where the power will be, I guess. And apart from that, yesterday it was also a discussion. Sometimes we need to make the bigger picture a little bit clear. Why are we doing this? And is it indeed that the main endpoint or not? So that's also something that we should take into consideration. So what will be the endpoint, and how much of fundamentals do you need to have a working product? I mean, do you need to know everything? Do you need to know the most important things? And also, what are the key drivers for your product, which will be used for practitioners or people which are sitting out there? So that's what I found the most important from the sessions we had yesterday.
Thank you, Shaya. I try to transcribe that in the slide as well. Are there other points that you see important to mention? Niti, you can also pop up at every time.
Yeah, I was just thinking if it's already covered in some sentences that you've already compiled, but I remember this coming up that we also probably need a set of indicators which provide information about the process. So probably a set of microbes or a group of microbes that we know from all the data is that is already being generated. So it's about selecting a group of microbes which could tell us specifics of the wastewater treatment process biology. I know we have these indicator organisms identified in terms of gut microbiomes. So something similar with the expertise of all people who have worked extensively on microbial ecology. We could have a set of members identified in these environmental ecologies as well.
Yeah. Thank you. And in terms of indicator, I think from the drinking water field, there are some set of indicators to guarantee the quality of the drinking water and the health of the consumer afterwards. So I think from at the wastewater treatment level, we can also get inspired from the drinking water field to think, okay, what are the key indicators that we need? What type of microbial indicators we need to develop? What is the essential list of information that we need to generate to focus then our analysis? Yeah, we had a talk from Feng Shu about the long channel in China, where they looked at the succession of microbial populations in the theoretical ecology session. And when we think about after the wastewater treatment plant and surface water or channel water, we can think what are the microbial indicators that can also lead to more faster to get an information about the potential impact a bit more fast So before there is a health issue, what are the microbial indicators that we can target that can give an early warning of an environmental problem and health problem? And that is something that we will also cover today on these sessions about water and environmental health protection with Michael, Ade, and Colin notably. So here we will go further with these microbial indicators, and I think it's a nice end word for this early session now from Niti. Yeah, what type of microbial indicators we can develop to guarantee the health state of a process, the health state of a water, the health state of a community in the end. So how can we bridge microbial communities and communities of citizens? Yeah, this can be a good point. Thank you. So now there are the poster sessions. So please interact, use this time to interact between each other. In Dryfta, you can always make a round table. You can generate rooms to discuss together. So the aim is to interact, use this time to interact. If there are some posters that you still want to look at, you can read them. You can look at the videos. And we see each other again in around 45 minutes. It will be at 9:30. Central European time, and we will start with the presentation of Michael Gillings on the rapid rise and dissemination of antibiotic resistance in the Anthropocene. So thank you very much, Francesc, Sergio, colleagues on site, and again, Romy and Nicole and Zeb online for the stable platform that you offer us. Thank you so much. And thank you for being here this morning, afternoon or evening by you. And we see you in 45 minutes. Bye-bye.